Okay, now, just with this tutorial, as we talked about on the previous section about what do we mean essentially by checking a model, and the example which I had on, for example, the machine that is going to create and just transform someone like you into an exact copy, and we saw that how we can just use that principle in terms of checking, let's say, for example, the model that we have created. I'm going to, in this tutorial, talk about another concept that is going to be crucial as an intuition about posterior predictive checks. That's the thing which you just want to do at this tutorial. But now, before we just go on to just use some codes in R, I should say, and some programming in the R, let's come here and talk about something that, for example, imagine that you are just going to work as Sherlock Holmes. And the task that you have is this. Imagine that you have, for example, for a task that you have to identify, for example, someone who has committed a murder. Imagine that, for example, you have a line, and we have, for example, let's say, for example, for this one, we have a probability, and this one represents, for example, the person who are just going to be as a suspect of the murders. For example, at this line, you have, for example, someone whose name is, for example, Sam. You have here, let's say, someone who is called, for example, George. Here you have someone whose name is, for example, Rod, and someone here who's also a suspect who has done, for example, the murder. It's a potential suspect for the murder, and let's call that, for example, Steve. And now you are just working as a Sherlock Holmes, and you see that before you just start your investigation, and if you have, for example, all of those 4 people as a suspect who has committed a murder, you can say that, okay, there is equal likely that each of these individuals who has committed that, I should say, that murder. Then you say that, for example, there is a 25% probability of each these 4 people who has committed the murder, and that's what we say that, okay, before our investigation is going to be this. Now imagine that for the second part of the lesson, for example, for the second phase of your investigation, you have done some investigation and you have been able to draw some evidences against some other candidates as the potential murderers. That, for example, you see that, for example, Sam is going to be not a potential murderer. Then you are just going to remove Sam from the short list which you have, and you have, for example, now you have 3 candidates, which is going to be, for example, George. Now another potential murderer is going to be, for example, Rod, and another potential murderer is going to be Steve. At this phase, you see that, okay, now from this picture, you are ending up, after having some evidences, you are coming with another distribution of the murderers. Look at the word which I'm talking about, another distribution of the murderers, which now each one is equally to have, for example, 3.3% likelihood that they have committed the murders. Then you see that, for example, from this picture that we have from here, going to this picture, after having some evidences about your, for example, your posteriors, you see that, for example, from this likelihood, we just came, I should say, after having some evidences behind coming to this distribution, and now you see that right now here, you have another distribution of the outcome which you are interested for, which is essentially to identify the murderer as a Sherlock Holmes. When you have new observation, then you have been able to update, let's say, your prior belief about, for example, the potential murderers. And imagine that, for example, on the other pictures which I have, for example, here, I come here and show that here with a new, I should say, evidences that I have, and I say that, for example, George is going to be removed from my list. then I have essentially here, for example, I have two potential murderers. For example, this one is going to be Rod and this one is going to be Steve, and you see that, for example, each one essentially there is a 50% probability that each of these individuals has committed the murder. And now you see that after getting another evidence, you have been able to update your prior belief to just have another distribution. And that's what we call that, for example, the posterior predictive, for example, distributions of, let's say, of my scenario. And at the end, you say that, for example, having obtained another further evidences, you can come here and say that, for example, there is only one person is left as a potential suspect, which is, for example, is going to be, for example, Steve. And you say that Steve, for example, there is 100% probability that Steve is a person who has committed the murder. And that's essentially, you see that by doing so, I have been able from this posterior distribution to base having updating my prior belief to just come to another distribution in my scenario. And as a Sherlock Holmes, you see that the job which you are doing essentially is to update your belief based on the results of the prior investigation results which you get. Then you update continuously your posterior distribution based on the information which you get, which acts as a prior on your, for example, on your investigation. And essentially that's the thing that we're going to talk about that, and that's what we call that as a posterior predictive distribution, that you update your prior belief and you update your posterior at every second, that you are just updating your prior, I should say, belief. And essentially, when we just come to talk about that in the mathematical formula, we talk that, for example, imagine that the probability of if y, the outcome which I observed, based on, for example, the outcome which I have had, if I say that what is this probability that I observe, for example, this y, based on the prior observation which I had y, it's essentially the integration on the probability that we talk about, and we call that the observation, based on the theta as a parameter that you have, times to the probability of having that parameter based on your y. Given that, for example, you can just call that, for example, the likelihood, then you just add, for example, d of theta. And essentially, when we just go over into the R, when we say that, for example, if we just call that, for example, the posterior predictive distribution, essentially, that's the mathematical, I should say, the formula that we are just going to talk about that. It's essentially the same thing that we talked about before. For example, the case that you're acting and playing the role of a Sherlock Holmes and you're looking for a criminal suspect into, for example, into a population of 4 suspects, and now you have a distribution of them, and you're continuously updating your posterior distribution after updating your prior, and now essentially that's what we just put that into a mathematical framework, and we are looking for the probability of observing y based on, let's say, the outcome which we have, and we just come here to express that in terms of, for example, the likelihood that we talk about, for example, the function, and let's say we just we integrate that into the whole parameter, I should say, space to get into the posterior predictive distribution. On the next tutorial, as now we are done working as a Sherlock Holmes to get to understand what is the intuition behind the predictive posterior predictive distribution, on to the next tutorial we just move on to have some kind of graphical and visualized interpretation of what it means to work with the posterior predictive distribution and how we can just replicate, simulate the original data based on the model that we have proposed in the Bayesian framework.